Good day, guys. We are looking at more problems on volumes. So this question says, make a neat sketch of y equal to e to the power negative x. Show the strip that we use to calculate the volume generated. If the area bounded by the graph, which is that graph, the lines x equal to 1, x equal to 0, and y equal to 0, rotate about the y-axis. So you can see, once I go through the problem, I underline the important things in the question. So let's go. The first thing is, I'll write down all the equations in all the graphs, the equations of all the graphs involved. So I've got y equal to e to the power negative x, that's my first graph. There is x equal to 1, there is x equal to 0, and there is y equal to 0. But before we move from there, we must be reminded that x equal to 0 is a graph, and the other name is the y-axis. Y equal to 0 is also a graph whose other name is the x-axis. So from here, you can now sketch the graphs. So once I've sketched my graphs, I must confirm that I've got 4 graphs. Then the portion I'm shading is the portion surrounded by the 4 graphs. So once I put my x and y axis, or x and y plane, I'm done with 2 graphs. So the next easy graph is x equal to 1. So I can choose where I want my 1 to be. If I say my 1 is here, then this is the graph of x equal to 1. So now is the time to sketch the graph of e to the power negative x. At times, students don't know whether is it a curve moving this way or is it moving down. So if you don't know that, if you have no idea about that, it's still possible to pick it out. What you simply do is that the first thing you must remember, once you have 4 graphs like this, 2 of them are the limit of integration. So if I want to pick my limit, those will be my limit. Why did I pick these 2? Because limit must be right from the same axis. You see, it's x equal to 1, x equal to 0. I can't be using x equal to 0 and y equal to 0. The 2 limits must come from the same axis, either the x or the y. So it's easy for me to see that those are my limits. So these limits should guide me. I will take the lower limit, x equal to 0, I substitute there. If you calculate e to the power 0, you see yourself with 1. So it shows that that graph touches the y-axis at 1. So I'll choose where I want to put my 1. If I choose to put my 1 maybe here, it's fine. I know my graph must pass there. Then I do the same thing with the upper limit. If I calculate e to the power negative 1, which is the same thing as 1 on e on my calculator, all I will be checking is whether is this answer bigger than 1, so that knowing that 1 will meet there, then I go this way, or is it lower? So it is smaller than 1, so I'll have to quickly do that. E to the power negative 1, I see 0.368, so this is 0.368, that is smaller number than 1, so if 0.5 is somewhere there, 0.3 can be below it. So I'm sketching, I must not get it to scale, so it means 1 on the x means 0.3 there, so that's my 0.368, so that is where the meet, so you see the shape. That's how your shape goes. So this helps me to give a sketch of my graph. Don't forget, we are not trying to scale, by just seeing this shape, so that we can be able to now shape the portion surrounded by the 4 graphs. So all my 4 graphs, that is the portion surrounded by the 4 graphs. So this is the portion I am shaping. So once I shape this portion, the next thing is to put a strip. The strip is either supposed to be vertical or horizontal. So I have to test the portion to see which is the best. For a strip to be the right one, if I put it there when I'm shifting left or right, up and down, I should keep on touching the same graph. So if I try the vertical, you see that if I put it here, I'm touching this and this. If I shift to the middle, the same thing. To the left, the same thing. So it's obvious that the vertical strip should work here. But let's try horizontal. If you try horizontal, you see down there, you're touching the same 2 graphs. By the time you cross that point, 1 graph has changed. So it's a problem. Some other ideas would be that you cut the graph, the portion into 2 parts, and put a horizontal strip up and down and solve 2 areas and add it up, but that is a very long method. So there is no need for that. When you've got a short method, then you can just put a vertical strip, which will be going anywhere, whether the left, the right, the center of the area. Then that touches the x-axis. I'm putting my dx there just to remind me that my formula for volume was m dx. Since the strip touches the x-axis, it also reminds me that the limit, even though we already saw it from them, must be right on the x-axis. So finally, if I've gone for a vertical strip, since vertical is parallel to the y-axis, the vertical strip, it reminds me that the two graphs the strip is touching must be labeled using y. The first graph is the one passing above the strip, then the second graph is the one passing below the strip. Don't forget, x-axis has another name, y equal to 0. So those are my two graphs. That is my graph. Everything is in order. I've shaded my portion surrounded by the 4 graphs. I've put the strip. I've labeled my graphs. So now it's time to capture the formula for the volume. So for M6 students, all formulas for volumes are on page 5, but there are formulas there for disk and shell. If you're not so sure which one to choose, this is how you do it. If you read the question, it said y-axis rotation. That is what tells me how my formula starts. The rotation tells me how my formula starts, and how it ends. I look at my graph and see the strip. If my graph ends with has a vertical strip that is touching the x-axis, then my formula must end with dx. Then if you go now to page 5 of your formula sheet, you will see that graph, the formula cell. So it's 2 pi, the integral from a to b. On the formula sheet, we'll write x, y here. But if I'm looking at my graph, I will see that there is y1 above the strip, y2 below the strip. So I can simply replace that by y1 minus y2. But even if you leave it like that, it's still okay. It's not much of a problem, right? The way y2 is 0. Then you start substituting your information there, a and b. You read it from the x-axis, which is where you started shading, to where you stopped. Or if you still remember your limit up there, 0 to 1, then you've got your x. My y1 is the name of the graph, e to the power negative x. My y2 is 0, so this is all I need, dx. So at this stage, I'm having a product to integrate. So whenever you're integrating a product, it's either use substitution or by part. To know the right one, you try to differentiate one function and see if you get the other. If that works, then it's use substitution. If it doesn't, it's by part. So if I differentiate e, I'll never get x. Even if I differentiate the exponent, I'll never get x. If I differentiate x, I'll never get e to the power negative x. So this is by part. Again, on page 4 of N6 formula sheet, the formula for by part is like this. So that is the formula for integration by part minus the integral of f prime of x g of x dx. So now that we have settled for integration by part, you see it's working for a product. I need to choose how those things will match them. So to make a choice, there is this abbreviation called IMIT, which helps us to quickly pick a choice. Here, A stands for algebra, E stands for exponential. So if I look there, you see that algebra comes first, exponential is second. So that means algebra must be f, exponential must be g prime. So I will go on and select my f of x, the algebra. Then I must look for its derivative so that it fits this side, which is 1. Then my g prime is e to the power negative x. If I integrate g prime to get g, according to page 2 of your formula sheet, you get negative e to the power negative x. Then you can go back now to your volume. So our volume Vy is 2 pi into. Then I substitute into this portion of the formula. I need f and g. That will give me negative x e to the power negative x minus the integral of f prime g. So that it goes here. In my f prime g, I always like to take constants out. My constant is negative 1. So I'm left with e to the power negative x dx. So I'm only left with that integral, which is no longer a product. So I get my 2 pi in bracket negative x e to the power negative x. This will become positive, but when you integrate this, like you see there, it creates another negative. So this is negative e to the power negative x from 0 to 1. Then now we substitute our limit, the upper limit first. Everywhere there is x, I'm putting 1. So I will get negative e to the power negative x minus e to the power negative x, negative 1. I'm replacing every x by 1. Then I close the bracket. I start all over again. So I capture my 2 pi. Then I replace every x by the lower limit 0. If I put 0 here, all of this is 0. Minus, if I put 0 here, e to the power 0 is 1. So if you simplify that, this will give you negative e will give you negative 2 times 2 is negative 4, e to the power negative 1, then negative 2 pi times negative 1, this is negative 4 pi, e to the power negative 1, and this is plus 2 pi. Then you can go to your calculator to see what that gives you. I'll quickly do that to get 2 pi, then minus 4 pi, minus 2 pi minus 4 pi e to the power, where is my e to the power negative 1. So that gives me 1,660. So my volume is 1,660 unit cubic. So guys, that's how you get the volume by the shell method. This is again the shell method, because you see how your formula is. Each time you get 2 pi out is the shell, or if you start with v1 and end with dx is the shell, or in other words, your axis of rotation was the y-axis. If your strip is parallel to the axis of rotation, it's the shell method. Thank you very much.